Hello friends, this is the first class of Invincible Chemistry, and as you can see we have taken up the chapter of Coordination Chemistry. But you might be wondering why Coordination Chemistry at the very first class. Let me explain you. In this series we are mainly targeting the students of UG level, PG level, students those who will be appearing for entrance exams and other competitive exams of the same level. Hence, we have divided the whole syllabus of chemistry on the basis of marks distribution in the various examinations, difficulty level of the chapters, and putting equal emphasis on the three branches of chemistry into 27 parts or chapters. Among these, we have the coordination chemistry as the first chapter. So let's begin with coordination chemistry. Coordination chemistry is the chemistry of coordination compounds. But then, what are coordination compounds? These are the compounds which have a central metal atom or its cation bonded with coordinate bonds to various ligands. Now let us see how these coordinate bonds are formed. For that, at first, we should know about the ligands and the metal atom. A ligand is an ion or a molecule which have at least one lone pair which can be donated. That is, it is an electron-rich species. It can also said to be a Lewis base or nucleophile as it has the capacity of donating electron. On the other hand, the metal atom or its cation is an electron-deficient species. It can also said to be a Lewis acid or electrophile as it has the capacity of accepting electron. Now, when the ligand donates its lone pair to the central metal atom, there forms a coordinate bond between them. Next, we will be discussing about the types of coordination compounds. There are basically two types of these compounds, the neutral compounds and the ionic compounds. The ionic compounds can further be divided into three groups as these compounds may have the complex ions as cations or anions or both cations and anions. Let us go through some examples of this. Here is an example of a neutral compound. And why do we call it as neutral? It is because of the total charge of the compound which is 0. Now let's see an example where the complex ion is a cation. Here in this compound, what is the charge of the complex ion? As we know, the oxidation number of one chlorine atom is -1. Hence, for 3 chlorine atoms we have an oxidation number of -3. So, the charge of the complex ion here must be +3, which will only then make up for a total charge of 0 for the whole molecule. Let us go to an example where the complex ion is an anion. Here, since the oxidation number of one potassium atom is +1, so for 4 potassium atoms it is +4. And it gives a charge of -4 to the complex ion, which is why it is an anion. Now let us see an example where both the cationic and anionic parts are complex ions. Here we can calculate the charges of the ions in a similar manner as shown in the earlier cases and find that the two complex ions have charges of +2 and -2, which makes them cations and anions respectively. If you are worried about the calculation of oxidation numbers, you just don't need to. We will be dealing with it in our next class. For today, let us quickly go through the various terms in the formula of a coordination compound. For that, let us take two of the earlier examples. In the formula of a coordination compound, we basically have two parts, the coordination sphere and the ionization sphere. The coordination sphere is written inside the square bracket and consists of the central metal atom and the ligands as already discussed. The detail of the coordination sphere and the ionization sphere will be dealt in the next class. Thank you.